Hello, good day my friends. This is G Solutions. We find solutions in this channel for your needs. Today, let us solve this problem. We are to determine the voltage across the coil. And the circuit is that it has a coil that takes 6 ampere at a power factor of 0.6 lagging from a 120 volt source. And then there is a resistor 10 ohm to be exact connected in series with that coil. And then this combination was connected across a 220 volt source. So again, determine the voltage across the coil. Okay, so to be able for us to understand this problem, let us illustrate it. Now you have here a coil and I represent it to a rectangular box. So this is your coil. Okay. And this coil has a power factor of 0.6 lagging. 0.6 power factor. And current is flowing in this coil I, which is 6 ampere. And when you connect this coil to a source, okay, let's say 120 volt source here, okay, we are to first find the value of this coil. Okay, so let's say this is ZC. Okay, what is ZC based on this given variables, the current and the 120 volts in 0.6 power factor. So by using Ohm's law, we can easily solve for the value of our coil or the impedance of the coil at 0.6 power factor. By the way, this is lagging. Okay, lagging. It means that your coil is more inductive. Okay, so how do you solve for that? We have B is equals to I sub Z, and Z can be computed by manipulation of this equation. That will be B sub I. So in this case, we have 120 volts over the current, which is 6. But since this is in lagging, this will be positive. So we are to get the 0.6, the value of the angle of 0.6 power factor. So that is the inverse cosine of 0.6. Okay, so we have our calculator here. We can easily get 0.6 by having it type here, inverse cosine 0.6. It will give us 53.13. So we'll write it here, 53.13 degree. Okay, so since this is lagging, so this will be positive, 53.13 degree. So therefore, if we are to change this to rectangular, okay, we can get already the value of our impedance, specifically for the real or the resistor in the inductive reactance. Okay, so 120 divided by 6, okay, will give you 20. So this is 20 cis of 53.13 degree. Okay, and again, let us get the rectangular value of this one. So rectangular This is how I press it on this calculator. In your calculator, it may be a different way of pressing it to be able for us to get the value for the real for the rectangular part. Okay, so you have 12, and then the imaginary part is 15.99. So we'll just have the rounded up into a whole number, so that will be J16. Okay, so this is your R and this is your X. So this is now the value of ZZ. Now, according to the problem, there is a 10 ohm resistor added to this coil. So I will draw it again. This is your ZC, and then a resistor here, 10 ohms. Okay, and the problem says that this system is, or this circuit is connected across a 220 volt source. So I'll draw it here, the source. Okay, connecting this circuit to a 220 volt source. Okay, so what we are looking for is the voltage in this coil after it is connected at 220 volt source. So let me just name this as B sub C. So we are looking for B sub C. So to be able for us to get the value of the voltage here, B sub C, we have first to get the total current in this circuit. So I just have it named it as I sub T. So getting I sub T now, okay, I sub T, again the same thing that we have done here using Ohm's law. That will be the B sub T, total voltage T, over Z sub C plus 10 ohms. Okay, now you have B sub T given 220 volt, and C sub C, okay, the value of that, okay, actually this is your C sub C. I'll put it as C here. Okay, so that is 12 plus J16. I'll use the rectangular form, plus 10. Okay, so copying the numerator and then adding the denominator. The resistors are 12 and 10, so you have 22. Just copy J16. To be able for us to easily conduct division of this, we change this denominator to polar form, copying again 220 and getting the polar form. Okay, polar, that is 22 comma 16. Okay, so the polar form is 27.20. Okay, I'll write here the 27.20. Cis of the angle is alpha 36.03. Okay, so I'll write it here, 36.03 degree. Okay, now I'll divide 220 divided by 27.2. Okay, so it will give you 8.08. Cis of, this will be shifted to the numerator and the sign will change. It will become negative 36.03 degree. So this is your current total. Knowing your current total, we can now get the coil here using again Ohm's law. So the B sub C is the multiplication of your current that is passing through this coil multiplied by the impedance of that coil, that C. Okay, So we have already the values of that. For IT, you have 8.08, which is of negative 36.03 degree. Okay, this is multiplied to this is Z, which is 20. I'll get the polar form because it is much easier for us to conduct multiplication. So you multiply the outside part, 8.08 here, the same values of what is in my calculator, times 20. So that is 161.76. Okay, the angle is, you will just add the angle, so you have 53.13. okay, 53.13. okay, this is negative, so plus negative 36.03. okay, it will give us 17.1 degree. So your answer will be this one, 161.76, 17.1 degree. Okay, or in any other books, we just consider this outside value. Okay, but this will be your answer for the voltage across this coil. Okay, so this is how you solve a problem like this one, involving the power factor and the voltages, simply as applying the principles of Ohm's law and simple analysis, no? Okay, so this is all. I hope I contributed added learning to your learning desire. Thank you.